Hey everyone, welcome back to some more Algebra 1 review. In this video, I'm going to show some problems over chapters 6 and 7. I've also included section numbers in case you want to go back to that section and review. And again, if you want to pause and try these on your own and then unpause and check your answers, I think that would be a great idea. Or at the least, just kind of copy the examples as you see me do them. So in this one, we're going to solve the inequality and we're going to graph our solution. This is an absolute value inequality. So absolute value, we have to isolate the absolute value symbols first, and then whatever inequality symbol is left is going to determine whether it's an and or an or compound inequality. So one helpful way we talked about in class was we always said, read it out loud in kind of an extravagant medieval times kind of voice. So this says absolute value of 4c plus 5 is greater than or equal to 7. And that tells us it's an or. So greater than. I hope you guys remember that. So we're going to split it into an or. So first one is basically exactly the way it's written without the absolute value. Or we take what's in the absolute value and then we switch the inequality sign around and we make this -7 instead of +7. And then we're just going to solve each one separately. So we'll start with this one, -5. So 4c is greater than or equal to 2, divide by 4. So c is greater than or equal to 1/2. Or over here when we solve, -5, -5. 4c is less than or equal to, that'd be -12, divide by 4. C is going to be less than or equal to -3. So less than or equal to -3, or it is greater than or equal to 1/2. And now we have to graph it. So let's put 0 right here in the middle. And I'm going to count by halves. So this is basically -1/2. This is going to be -1. This would be -2. This would be -3, -4, -5, and then on the other side this would be a half. 1, 2, 3, 4, 5. So every tick mark represents a half. We also need to pay attention to the type of dot when we plot these and when we graph them. So the line under this tells us it's a solid dot at 1/2. So solid dot at 1/2, and it's greater than 1/2. So we're going this way. And then solid dot again at -3, and it's less than or equal to -3. So we're going this way. And it's an or, so that means the arrows go opposite directions away from each other. So here's our solution, and here's the graph that goes along with it. Here's another one. No absolute value in this one. It's just a compound inequality. You can see we have an inequality symbol here and here. So if you need to, you can draw lines down those to kind of separate your work. We want to get the variable in the middle here by itself. So whatever we do in the middle, we have to do to the left side and to the right side. So let's add 10 to all those spots. -15 plus 10 is -5. Drop down the inequality symbol. Now it's just 15p here. It's less than 30. Divide by 15. Over here we're going to get -1/3. Drop down our inequality symbol. And 30 divided by 15 is 2. So here's our solution. This says p is greater than or equal to -1/3 and less than 2. And don't forget, whenever we're solving inequalities, if we end up dividing by a negative, remember you got to flip the inequalities. So here's our solution. Let's graph it. Numbers are fairly small, so let's put 0 in the middle again. This time I'm going to make each tick mark worth 1/3. So 1/3, 2/3, this would be 1. 1 and 1/3, 1 and 2/3, this would be 2. 2 and 1/3, 2 and 2/3, this would be 3. And down here, -1/3, -2/3, this would be -1. -1 and 1/3, -1 and 2/3, this would be -2. This would be the -1/3, -2/3, this would make this -3. There we go. So p is less than 2, that means open circle at 2. This is a solid closed circle at -1/3, which is right here. And it's an and, that means everything here in between those two dots. Here's another inequality, just a basic inequality, only one inequality symbol, no absolute values. So we solve this just like an equation. So I'm going to take the smaller of my variable terms and move it. That would be the -3m. So I'm going to add 3m to both sides. That would give me 4 plus m is greater than or equal to 7. Then I'm going to subtract 4. And that says m is greater than or equal to 3. So again, put my 0 in the middle. I'll go every other one just to space it out. There's 1, 2, 3, 4, and 5. If you want, you can complete these over here. -1, -2, -3, -4, -5. M is greater than or equal to 3 means solid dot on 3, and it's greater than or equal to, so it goes to the right. That does it for inequalities. Now we're going to get to systems of equations. There's a lot of different methods for solving systems. There's substitution, there's elimination. You could graph them and see where they intersect, all sorts of different ways that we've learned. So you can use any of those in solving this. To me, I like elimination. So I'm going to take this bottom one and I'm going to multiply it by -2. That will make the y's opposite, and then they will eliminate. So I'm going to leave the top one exactly the way it is. And I'm going to multiply the bottom one by -2. So -2x minus 2y equals 6. Now these are opposites, so I can add 5x plus -2x is 3x. When I add the 2y and the -2y, they cancel, they eliminate. 9 and 6 will give me 15. And then when I solve this, I'll get 5 for x. And then I can go back up and take either one of these and solve for y. I'm going to take this one because it's the easiest. Not as much stuff in it. So I'm going to put 5 in for x. Subtract 5. And y is going to be -8. So my solution is really this ordered pair. The x value is 5, the y value is -8, so it would be 5, -8 as an ordered pair. Here we have a system of inequalities. So we're going to graph this. And when we really graph each inequality separately, we just need to realize it's an inequality. So there's going to be shading involved. So this first one, it's already in slope intercept. That's helpful. I'm going to take the second one and I'm going to rewrite it in slope intercept before I start graphing. That just really means get y by itself. So -2x. Then it's -6y is less than -2x plus 18. Divide by -6. Since I'm dividing by a negative, I gotta flip that around. So now it's y is greater than -2 divided by -6. That's positive, and it would be 1/3 when it simplifies. So 1/3 x minus 3. So here's slope-intercept form for the second one, and here's slope-intercept form for the first one. So those are the ones that I'm graphing. In fact, let me do this one in blue just so we can separate them. So y-intercept is -4. Slope is 2/3, so that means from here up 2 to the right 3. And I can just keep doing this and go as far as I want. Should be good. And then I draw a line through it. And it is a solid line because it's equal to. The inequality symbol has the equal to line underneath it. So I'm just going to draw this line through them and extend it. And then I also need to know which side of this line is shaded. So I'm going to test the point where we said use 0, 0. So if I plug in 0 for x and 0 for y, I'd get 0 over here. This would be 0 minus 4. So 0 is greater than or equal to -4. That is true. So that means I'm going to shade this side of the blue line. Now let's do the red one. y-intercept of -3, slope of 1/3, so up 1 to the right 3. I share that point right there. Up 1, right 3, up 1, right 3. This is actually a dotted line, so I'm going to have to make this a dotted line here. Right now it's going to be solid. I'll extend it and I'll change it to a dashed line here in a second. So there's the boundary line. Now it's dashed, so let's just get rid of some of these so we can tell that it's a dashed line. Like that. There we go. Now we need to test the points. You can test it either in the original or in the new one, it doesn't matter. I would probably stick to the original. So let's do 0, 0 again since it's far away from it. 0 here, 0 here, that's going to make 0 on this side. 0 is less than 18. That is true. So we're shading this side of the red line, and I need to envision where these overlap. That's really going to be the side that I shade. So I'm above the red line and above the blue line. Right here, I'm not above the red line. Right here, I'm not above the blue line, but right here, and then over here above the blue, this area is above the red and the blue. So that would be my solution. All my solution sets would just sit in that space. Here's another system of equations. We're going to solve just for x. So keep that in mind, just for x. That means we want to either get rid of y or make it so that we're only solving for x. No need to solve for y if it's only asking for x. So this is saying y equals 2x. What I'm going to do is I'm going to use substitution. I'm going to take this 2x and I'm going to substitute it for y right there. So the top equation is going to become x equals -4 times what I'm substituting, which is this 2x. So just in place of y, minus 13. So this is the only thing that changed. It became 2x. Now my equation is x equals, my multiply would be -8x minus 13. And now I can solve for x. So I'm going to add 8x, 9x equals -13, divide by 9. A little bit messy, but it looks like x is going to be -13 ninths. And that's all that I have to do. Just x, it says. So -13 ninths. Find the solution for x again, just x in the system of equations. So this one looks more like elimination to me, not substitution. If I'm finding x, that means I want to get rid of y. So I'm going to multiply this bottom one by 2, and then I can get rid of the y's. So 3x minus 2y equals 3. First one's going to stay the same. Bottom one's going to become -2x plus 2y equals 2. And these are opposites now, so I can just add to eliminate them. 3x plus -2x is x. The y's cancel. 3 plus 2 is 5. X equals 5. And I'm done. I don't have to do anything else because I'm just solving for x. Last one, story problem, and we'll be done with chapter 6 and 7. So Sam sold more items for the fundraiser than Jim. So Sam sold more. The difference in the amount of items they sold was 8. Together, they sold 32 items. Let S equal the total items Sam sold and J equal the total items Jim sold. Set up a system of equations to represent the situation. So I need a system of equations. I need 2 equations. I'm going to use the fact that the difference, meaning subtraction, between the two was 8, and the fact that Sam sold more. So that means S minus J equals 8. And then the other thing that I'm going to use is that together they sold 32. So this is an addition problem. Together they sold 32. So S plus J equals 32. So there's my system. Now I'm going to answer how many they sold each. So rewrite my system here. If I just add these together, the J's are going to cancel. So I'm going to add them. It's going to give me 2s equals 40. Divide by 2. So that tells me Sam sold 40. And now I can use that to figure out J. So I'm going to use S plus J equals 32. I know S is 40, so 40 plus J. Sorry, not 40. That's my mistake. I divided it by 2, right? Just thinking. It doesn't make sense if they sold 32 together. Couldn't have possibly sold 40. Sam sold 20 items, right? 20. Let's make this 20. 20 plus J equals 32. That's much better. My mistake. 32 minus 20 is 12. So Sam sold 20. Jim sold 12. So barring that mistake, I hope that helps you with chapters 6 and 7 on your Algebra 1 review. Have a great day.